Alright, I was cut off kind of rudely. We're looking at this one. We're going to write a function of the form a y equals a secant bx minus c plus d, or y equals cosecant, or y equals tangent, a tangent, or y equals a cotangent of the quantity bx minus c plus d. Alright, now that means we have to identify what curve it is, right? They're not telling us that we do it in each of those, just which curve is it. So this is secant or cosecant. And so I graphed the sine or cosine that corresponds to that particular secant or cosecant. What I've done is identified that curve as, so the dotted line, the dotted curve that I've filled in there, I don't know if you can see it. You can see it better. So I've identified this curve that's associated with the given graph, and this curve, because the graph has a point at pi over 4 comma -1, and then there's a u that goes down from there, and then at 3 pi over 4 comma 1, and there's a u that goes up from there. So I graphed in a sine wave, but it's upside down. Okay. It's upside down, goes from 0 to pi, but it's upside down. But if I were to consider what is the equation of that sine wave, it would be y equals negative sine of 2x. Because the period goes from 0 to pi, right? So you have the 2x. So that's the equation of the sine wave. It'll be the same for the secant. I'm just going to replace the sine with the secant. So my actual equation for the actual u's that I'm given is y equals negative, and the sign is related to the cosecant, so this will be negative cosecant of 2x. Okay, well, and so notice I find the equation for the sine, and then the cosecant just replaces the sign. Okay, so that should be the equation for that curve, and of course we'll graph it on Desmos, and we'll double check it. We'll leave number 2 for class. Alright, and that's it for section 5-6.